Hey everybody, this is Mr. Beckstrom, and today we're going to take a look at some examples and go over some problems from sections 1.3, 1.4, and 1.5. So we'll go ahead and start here with section 1.3. I gave some examples here. There's also a lot of examples in the My Math Lab if you check view an example or help me solve this. So let's go ahead and get started here. All right, the first one says convert to a percent. So we're going to start with 3 7/10, and they want us to convert that to a percent. So if I'm dealing with a fraction, which is a mixed number, improper fraction, the first thing I want to do is I want to convert that to a decimal. Now, how do I convert that to a decimal? Well, this is really the same thing as just 3 plus 7/10. That's how I'm going to think about it here. And I'm going to go to my calculator, and this will work in just about any calculator that you have. And we are going to go to 3 plus, if you want to put that in parentheses, you can, 7/10, the fraction. And you get 3.7. So that is that in decimal form. And then to put that into the percent from a decimal, what we do is we move the decimal place 2 to the right. So that's going to be, and we add the percent sign. So that'll be equal to 370%. And that would be the answer for that one. Because we go 1, 2, and since there's nothing there, we're going to have to add a 0 there. And so that's it for that one. Let's take a look at the next one here. The next one says convert to a decimal number. So we're really just going to do the same thing with this one, except we're going to stop after that first step. So I'm going to do 17 plus 1/4 and go to my calculator, and we're going to do 17 plus 1/4. It's always a good idea to put your fractions in parentheses. You don't have to, for example, with this one, because it'll do the division before addition due to order of operations. But when you're multiplying fractions, you definitely want to put them in parentheses. So it's just a good habit to always do it. And going back here, hit enter. That's going to be 17.25. So that's 17.25. And then we stop there. If they asked us to put this in percent form, we would just move that decimal places 2 to the right, and then we'd have 1,725%. All right, this one says change the percent to a fraction or mixed number and then simplify. All right, so we're going to start with the 53%, and they want us to change that to a fraction or a mixed number. Remember, a fraction would just be like the 7/10, and the mixed number would be the 3 with the 7/10 like that. So in order to first convert this to a decimal number, which is what I want to do first, or there's a couple of different ways to do it. Let's actually just use the percent rule. And that means that if you have a percent, that's the same thing as saying that number divided by 100. Why? Because dividing by 100 moves that decimal place 2 to the left. So I can write this as 53/100 and drop that percentage there because I'm dividing by 100. And here is our fraction there. And then they want to make sure that we put this in lowest terms or to simplify that fraction. So there's a couple of different ways to do it. One way is if you have a TI-30XS multi-view, you can just do 53 divided by 100. It'll give you a decimal point. It'll give you 0.53. And then you can hit the little double arrow key on the bottom right, and it'll convert it to the lowest possible fraction. Or if you have a TI-83 or TI-84, you can do it like this. You do 53 divided by 100. Enter, and then we can convert that to a fraction. So we get math and fraction there, and that 53/100 is in the lowest form there, and you are done. All right, and then the last one here says rewrite the percent as a fraction in lowest terms. So let's do that again, same thing. So 14%, that's going to be equal to, we'll just drop the percent, right? That is 14/100. And again, we want to see, I already know that both of those are divisible by 2, so I know it's going to simplify further than that. But let's have our calculator do that for us. So we do 14 divided by 100. It gives us a decimal, and then we hit math fraction, or if you're using the TI-30XS multi-view, you can just hit the little double arrow key, and that actually reduces to 7 over 50. So that's equal to 7 over 50. All right, try some more of these. Most of the ones from section 1.3 homework are just like these. They're real quick, so it shouldn't take you too long as you understand the rules. If you have any questions, let me know on those. And now let's take a look at some examples from section 1.4. All right, so for section 1.4, one very important thing that we need to know is a certain way to set up a proportion, and that's P over B is equal to R over 100. So P over B is equal to R over 100. Now this is where the P is equal to the part. So that's usually the part of the fraction there. The B, that's equal to the base of the fraction. Sometimes we call that the whole. Oops. I was spelling whale there, wasn't I? The whole. All right, the R is equal to the rate or the percentage, and then 100 is just going to stay 100. So let's talk a little bit about what these mean and how we identify them. So we have the part and the whole of a fraction here, and we're going to have keywords to kind of let us know what is what. And the keyword for the part is the word is. So when we're doing these word problems, which we're going to do, we're going to look for the word is to kind of identify what the part of the fraction is. And then for the base, we're going to look for the keyword of. And then for R, we're going to look for kind of a percentage. So if they give a value that's a percentage, or they ask for a percentage, that's talking about the R. And then 100 will always stay 100. All right, so let's go ahead and take a look at a specific example here. All right, so for this one here, it says 8.5% of $250 is how much money? All right, so we're going to use this here in order to kind of identify our variables. We should be able to replace two of these variables, which means that we're just going to be solving for the last one. So here, I can see that my R, which is going to be equal to the percent, the rate of the percent, that's 8.5. I'm going to go ahead and write that as 8.5. Just makes it a little bit easier. If you were unsure of that, you could always go to your calculator. Just do 8 plus 1 divided by 2. That should give you 8.5 there. The word of here is associated with 250. So remember, of is our base. So our base is going to be equal to $250. And then is kind of blank there. So that means that we're going to be solving for P, right? So that's our unknown. That's our unknown. So now putting these values in here, we're going to leave the P there because that's our unknown over the base, which is 250. And that's going to be equal to our rate, which is 8.5. We're just going to leave that in that percent form, all over 100. All right, and then we're just going to cross multiply and divide. So 100 times P is going to be equal to 250 times 8.5. So that's going to be 250 times 8.5. And that's going to give us 2125. So 2125. And then we're just going to divide both sides by 100. By 100. And that's going to give us P is equal to, dividing by 100, moves the decimal place to the left, So 21.25. So 8.5% of $250 is 21.25. And think about it, 8.5% is about what the sales tax is on something. And if you were to buy something that was $250, would you expect the sales tax to be around $21.25? Sure, that value definitely makes sense there. All right, let's take a look at another example. Okay, 75 is 33.33% of blank. So let's go ahead and do the same thing. And remember, it's always a good idea in these videos, if you can, go ahead and pause the video after you see the problem and see how far you can get on it and work it out. All right, so we are going to start with this. So this is 75 is, so that's my is part, so that's going to be my P there. So P, oh, that's a horrible P, isn't it? My mouse is starting to skip here. P is equal to 75. All right, now that 33 1/3%, that's going to be our R. Now, this is a little bit of a tricky part. Normally, if I can, I will convert that to a decimal. However, if you go to your calculator and you do 33 plus 1 divided by 3, you are going to get a repeating decimal. So what does that mean? That means that we can't really do it in this instance. So if you get a repeating decimal, then we're just going to have to keep it as a fraction. But what I am going to do is I'm going to turn it into a improper fraction. And I sent out a video on that earlier, but this is how we're going to handle this one. So the is 33% of, well, the 33%, we know that's the percent, so that's our R. And I'm going to, so 33 1/3, to write that as an improper fraction, you take the whole 33 times the base here, so that's going to be 99, plus the top of the fraction, which is 99 plus 1 is 100, and you're going to put that over the bottom of the fraction. So to write that as an improper fraction, it's going to be 100 over 3. Your TI-30 excess multiview has a function there that converts numbers into improper fractions as well. All right, and then the of, that's going to be our base. Our base, that's going to be our unknown in this case. All right, I think that was, wasn't that our unknown in the last one too, or was it the, all right, no, that wasn't the same one as our last one. So now, putting this in here, I'm going to have P, which is 75, over B, which is our unknown, so I'll just leave that as B, is equal to 100 over 3. That's our rate, all over 100. All over 100. And now I'm going to cross multiply, so I'm going to get 100 over 3 times B is equal to, and then 75 times 100 is 7500. Now, I think the last time I showed you, I divided both sides by this fraction, which then you end up having to do the multiply by the reciprocal of the denominator, which is a fine way to do it, but there's a slightly easier way to do it if you're comfortable with it, and that's just multiplying. If you have a fraction times our variable here and you're trying to solve for that variable, just multiply both sides by the reciprocal of that fraction. So the reciprocal of 100 over 3 is just 3 over 100. And then you have to do the same thing to the other side, 3 over 100. What that'll do is the 100 will cancel out, the 3's will cancel out, you're just left with your B. And that's going to be equal to, and then we're going to multiply fractions, so you do the tops. So 7,500 times 3. So 7,500 times 3 is going to be 22,500. So this is going to be 22,500 all over 1 times 100 is just 100. And divided by 100 moves the decimal place 2 to the left, so this is just going to be 225. So that means that 75 is 33 1/3% of 225. All right, let's go ahead and take a look at one more example from this section. Okay, for this last one, I wanted to take a look at one that might not follow our specific rules for this, but one that we should be able to figure out. So if you want to go ahead and pause now, give it a try. It says if you answered 50 problems correctly on a 54 question test, what % of the problems did you answer correctly? All right, so go ahead and give it a try, and then we'll go through it. Okay, so it's asking what %. So in this case here, I know that my R, horrible R there, try it again, my R is going to be our unknown there. So that's what we're going to be solving for. So that means that I should be able to find a P and a B. Now it doesn't really use the words is or of. However, one of them is going to be 50 and one of them is going to be 54. So this is where we have to really kind of take a look a little bit at logic. So one of these is going to be the part of the whole, and the other one is going to be the whole. So which one is the whole? How many total questions are there? And that answer would be 54. So that's going to be our whole, or our base here, 54. And the 50 problems, that's going to be the part of the whole that we're talking about, right? So this will help us out in a lot of those, but not all of them. Not all of them. Sometimes we have to just work them out. So now we can write this as 50 over 54 is equal to R over 100. All right, cross multiply. So we're solving for the %. So 54R is equal to 50 times 100, which is 50, and then add 2 zeros. And then we're just going to divide both sides by 54 in order to solve for R. So R is equal to 5,000 divided by 54. So let's pull that up. 5,000 divided by 54. And what does it say to, let me see on the actual problem. It says round to the nearest whole number as needed. So the nearest whole number would be 93. Why? Because the whole number is the number that's to the left of the decimal place, so we want to round to this. So it's either going to be 2 or 3, depending on whether the number on the right is 4 or less or 5 or higher. Since this is 5 or higher, we're going to round up, so 93. So this would be 93. What does that mean? It means that if you answered 50 problems correctly on a 54 question test, your grade, rounded to the nearest whole number, would be a 93. All right, guys, let's go ahead and take a look at a few examples from section 1.5 now. All right, so this last section we're going to be taking a look at in chapter 1 is on special applications of percent calculations. Basically, it's going to be using this idea of a proportion, but it's going to be using it in real life applications. So we're going to have a whole bunch of different proportion formulas in here. So you might want to just have your book or the ebook out and take a look at them for each problem. So let's take a look at this first one and see how we would solve it. So it says a CB radio is rated at 7.5 watts. And actual measurements shows that it delivers 6 watts or 6.0 watts to its antenna. What is its efficiency? All right, well, if we look up the efficiency proportion formula, you can find it on page 63, and it looks like this right here. So to find the efficiency, we're going to use this one. The output over the input is equal to E over 100. And you can also think about this as, the part over the base. And here we're solving for E, so we need to know which one of these is the output and which one is the input. Well, what's the total possible amount of watts? And that would be whatever it's rated. So that's going to be our input here. That's going to be the whole. And then the amount that it actually delivers was going to be the part of that whole, which will be the 6.0. So we can go ahead and write this out like this. 6.0 over 7.5 is equal to E over 100. And then we're just solving our proportion problem. So this is going to be 7.5 times E is equal to 6 times 100, which is just 600. And then we're just going to multiply both sides by 7.5. And so 600 divided by 7.5, let's pull that up. So 600 divided by 7.5, and we get 80. So E is equal to 80. So that's our efficiency rating for this problem here. Okay, so for the next one here, an iron casting is made in a mold with a hot length of 16.3 inches. After cooling, the casting is 16.15 inches long. What is the shrinkage in percent? Alright, so now we're trying to figure out what is the percent change? How much is this thing getting larger, or how much is this thing getting smaller? How much is it increasing, or how much is it decreasing? So for this, we are going to go ahead and use the percent change formula. That's on page 66 in the book. So it's going to look like this. So to find the shrinkage percent, first find the amount of decrease. That is the difference between the original length and the length after cooling. Then use the following percent change formula here. Okay, so how much did it shrink? By what? Remember, it says find the difference between the original amount and this new amount. So to find the difference, we just do subtraction. So 16.3 minus 16.15, and I think we're going to get 0.15 back. We are. So 0.15 is the amount of decrease here. So 0.15 divided by its original amount. The original amount was 16.3. So 16.3, and this is equal to the percent decrease here. That's what we want to know, all over 100. So now that we have the proportion set up, we're just going to cross multiply and divide. So 16.3 times R is equal to 100 times 0.15. So we're just going to move this 2 to the right. It's equal to 15. So now we're going to divide both sides by 16.3 to get R by itself. And R is equal to 15 divided by 16.3. So 15 divided by 16.3. And I think the problem asked to, let's see what it wants us to do here. It wants us to round to 1 decimal place. So 1 decimal place would be to right here, so that's going to be 0.9. It'll stay at 0.9 because the number to the right of that is 4 or less. So this is 0.9%. So slightly under 1% is the amount of the decrease, because 0.9 is slightly under 1. So barely any decrease, really, so almost 1% decrease. All right, let's take a look at one more from this section here. All right, so for this last one here, this is one I always get a lot of questions on. And it says the pressure reading coming out of a pump is 175 pounds. Every 50 feet, this section reduces the pressure by about 2%. So this pressure in this long pipe here is decreasing every 50 feet by about 2% of that amount. What will the nozzle pressure be at the end of the 6 50-foot sections? All right, so let's go ahead and see how we're going to solve this. All right. So in this case here, we are trying to find basically whatever the new value is going to be each time it goes through 50-foot section. So we can kind of write it as this. This is on page 67 in the book here. And so if we think about it, the new value after a 50-foot section, so after, let me write this out, so after 50 feet, after 50 feet, we're going to be solving for the new value, so I'll just leave that as a V, over the original amount. So it started at 175 pounds, so that would be our original amount. And that's going to be equal to 100% minus the percent decrease. That's 100% minus 2%, so that'll be 98%, all over 100. You cross multiply and divide, you're going to get 100V is equal to, I think I already did this in my calculator, is equal to 17,150, 17,150, and then if you divide both sides by 100, you'll get V is equal to 171.5. Alright, so that means that if it started at 175 pounds, after one of these 6 sections, it's going to reduce by 2%, and it's going to become 171.5. Now let me show you a much quicker way of getting that 171.5. We could have also just multiplied that 175 times 98%, and 98% in decimal form, we can write that as 0.98. And look, we also get that 175 that way. So for the rest of the calculations, I'm just going to basically use the shorthand or shortcut product here, and that's I'm going to take the new amount and multiply it by 0.98. So you're going to take this, so this was the first section, so the second section we're going to multiply that by 0.98 again, and then we're going to multiply that for the third section by 0.98, and then for the fourth section by, kind of messed up here. Let me start over here. So after the first section, we had 171.5, and then we're going to, for the second section, we're going to multiply that by 0.98. For the third section, we're going to multiply that by 0.98. For the fourth section by 0.98. For the fifth section by 0.98. And for the sixth section by 0.98. So we can just do it like that. And this means that after it goes through all 6 sections, our total is going to be, our water pressure is going to be 155.02 rounded to 2 decimal places, and that'll be pounds. All right, the view and example in that problem is also there, and it kind of goes through a similar calculation there. If you have any questions at all, please let me know. Feel free to post in the forums, and I hope everybody has a great week. Thank you.